Okay, so I'm so glad you can see. So let us start from the current slide. And so today we are going to speak about describing a process. So the process that that is necessary for your master degree thesis. And so we are going to speak how to do this. And there are several questions here. What processes do you need to describe in your field of research? Duman, do you need any processes?
I don't know.
Think a little. What kind of process?
I mean, field это типа физика или специальность?
Your thesis, you're writing your master degree thesis, right?
Oh, okay.
What kind of process?
Maybe about transmission of waves. Maybe about codes.
Codes. Okay. Coding, yes.
About digital modulations.
Okay. So, and Aidana, what about you? What kind of processes are important for you now?
So the processes, I'm still thinking about it. It's like, you mean like a physical, chemical like this?
No, that should be like connected with your thesis paper, with your paper. You are writing about nanotechnology, right? So are you describing any kind of process in your paper?
Yes, I am describing the process of implementation nanosatellite learning into the STEM education.
Great, okay.
So that is the...
I see. And the question is, who do you describe them for? Who needs your description?
Researchers, students.
Yes.
Like it's useful in the educational sphere, scientific sphere.
Okay. So before the students can read your paper, there should be some kind of, it should be published, yes? Somewhere. And so it should be published in such a way that the other scientists can read it and so understand, right? So, and the question is, how much detail do you need to include in your descriptions? Should the description be detailed or not?
I think it should be brief, but it have to be understandable.
Right, you're right. So, and okay, and why should we need to include details? Why should it be understandable? Why is it important?
I think first of, I think the idea of any research is just about ознакомить.
So no, maybe.
Learn. Ознакомить других.
Get acquainted. Inform, yes, inform. I think.
I think the main idea in research is to inform the other people about what you do. And when someone searching for something, for example, someone wants to, for example, develop, for example, nanosatellites, something around nanosatellites, okay? And then he search something around this. He or she don't need any details about it. First of all, he searched something similar. And I think the description, first of all, should describe the brief information, not detailed. So someone who interested in can collect all of this, then reading introduction and other parts more detailed, ну, познакомиться более детально с этим проектом.
You are speaking maybe about the abstract, which shows the main information, what the paper is about, what the article is about, right? Abstract. So this is
Да.
of any kind of paper, scientific paper or scientific article. But it's also important to include the details. Why is it important? So in such a way that the other scientists can just repeat the same process, the same experiment that you describe in your paper, so that they can understand that your paper is valid and it follows some kind of, so this is scientific paper and anyone can repeat the same actions and get the same results. So that is why it's important. So when we speak about scientific vocabulary, here we have some very specific words with prefixes. Let us look at this chart and match the beginnings from 1 to 9 to the endings from A to I to make definitions of the words which are given in bold. So you can see that some words are in bold and the prefixes are highlighted with the are highlighted in red here. Приставки здесь выделены, да? So, for example, the first phrase here, the first sentence is shown. A biodegradable substance is one which decays naturally. То есть
Decays. Что означало?
decay — разлагаться, распадаться. То есть what's Russian for biodegradable? Биоразлагаемые вещества — это те, которые разлагаются естественным путем, right? So you can see that decays gives the definition for biodegradable. What about the second line here? Aidana, will you read it and find the second part?
A nanocapsule is a capsule which has
Наверное, Аша.
it's the H, I think.
Yes. A
Nanocapsule is a capsule which has a diameter smaller than 200 multiplied on the 10 in the degree of -9 meters.
Yes. So this is very small. Do you see? Nano means very small. Okay. So Duman, what about number 3?
A removable object is one which can be put in one place, taken, and then taken away again.
Right, you're right. So, Aidana.
Okay, in the kytosis or cytosis?
Endocytosis.
Endocytosis is a process by which, it's the process. Okay, molecules can move inside cells. Maybe it's G.
Yes, G, you're right. This is endocytosis, like inside. Yes, endo. This is the meaning of the prefix endo. Inside the cells. Okay. So demand number 5, please.
If a cell overexpresses a protein, it expresses too much of it.
Exactly. So overexpress means produce, over means too much. This is the meaning of the prefix over. So Aidana, number 6, please.
If someone is giving multiple doses of a drug, they receive
the same.
They receive it many times.
Yes, multiple doses, like many times. They get the doses many times. So multi means many times. Yes. Okay, Duman, number 7, please.
Intercellular communication is a communication which happens between cells in the same organism.
Yes, between cells. This is intra means between. This is the meaning of this prefix. The next one, Aidana.
When a drug is encapsulated, it is so maybe it's I, but I'm not sure. I don't think so.
No, we've used I already.
It's
Okay.
E.
Yes, can be put in one place and taken away again.
No. This
No,
is
E put inside something else.
No. When drug is encapsulated, то есть когда encapsulated, выходит, да?
капсула. Когда лекарство заключено в капсулу, это означает, что
Put inside something else.
Molecules can move inside cells.
We have already used this. Molecules, but this is E, put inside something else, да? То есть она, drug лекарство помещено внутрь чего-то, да, в какую-то капсулу. So this is E. Okay, Duman, the last one.
You ingest this substance, you take it. Который остался? Это B? In your body.
Okay. Ingest a substance. Когда вы поглощаете какое-то вещество, оно попадает, это значит, что оно попадает вам в тело, внутрь тела, да? So ingest, you know, digestive system, система пищеварения. Ingest, поглощать что-то, съедать. Yeah. Okay. So here are the answers, actually. So we were right about this, biodegradable. So this is about decaying naturally. Nanocapsule, this is a small in diameter, removable, which can be put in one place and then taken away again. Endocytosis is inside the cells, внутриклеточные. Overexpress is overproduce, to express too much. Multiple is many times. Then intercellular means also this is between cells in one and the same organism. And encapsulate, this is put inside a capsule and ingest, take into your body. And here we can see the so the meanings of the prefixes. So one more time, Aidana, can you comment on the meaning of these prefixes? What do they mean?
So bio means that is the natural, right? Nano is the very small. Nano, it's in the mathematics and physics, is the syntaxis of the meaning of something very small. Re is the prefix we use for showing that we are redoing something. For example, reconstruction. Also, into. To be honest, I don't get this one.
So
and
this
is a process by which one can move inside. Yes, so before I didn't get it. So it's the you said that indo, it's like inside,
right?
So showing the process inside of something.
Okay.
Over, it means not inside, but it's over, like
outside. So over is have a look at this slide.
Yes, but also like it's another meaning. When we say over, it also means like something of like express too much of it. Yes, but we do also use например overworking, например, да? And that's what I meant. Multi, which means that there are a lot of something.
Several times, yes?
Yes, several times. Inter also means like an into. Inter is,
okay. And
it's like communicational.
between.
Yes.
Between. We know international, this is between the nations. Between the cells, right? Okay.
So this one, it means that inside of something, put inside of something, it is kind of the same like into.
Yes. And also in like in digest also means inside of something, right? So
Yes.
I mean, if we know the meanings of these prefixes, we just can make new words, and we can easily understand the meaning of new words which are made with the help of these prefixes. So, and we started speaking about nanotechnology. What is nanotechnology? So, Aidana, you are a specialist in nanotechnology. What is it?
Nanotechnology, it's the technology that has a very small size, 10 in the power of -9, which can be seen in a molecule, like in the laboratory way.
Great.
So this is nanotechnology.
And if we speak about commercial applications, so what commercial applications could research in nanotechnology have? Duman, what do you think about commercial applications?
I think commercial applications of nanotechnologies are already used.
Many examples.
For example, nanotubes, which use it in all of high-tech technologies. For example, in, development of antennas, telephones, laptops, and all the stuff.
Okay.
Another thing is, for example, in medicine, we use the nano
Technology.
лекарства. And nano
drugs, nanomedicine.
Nano drugs, nanomedicines, maybe, for example, which help us to, for example, find. One of them helps us to find, for example,
fight with what?
Раковые опухоли.
Yes, with the cancer tumors.
Cancer. Who can find and analyze the cancer, for example?
Exactly. Yes, good. Okay, and so this is like.
Yeah, we know it about it.
So the definition of nanotechnology, which Adana has already said. So structures with the size of 1 to 100 nanometers in at least one dimension. A nanometer is, as you've said, 10 in the power of -9 meter. And so the example is a human hair has a diameter of about 60,000 nanometers, and a sheet of paper is about 100 just 1,000 nanometers thick. So, and you see that nano structures are even much more smaller. Okay. Now we are going to speak about one specific process which is described here in the picture. So one application of nanotechnology is in pharmaceutical research. So pharmaceutical means connected.
I heard it.
Yes, connected with drugs. Yes, drugs which are which get inside a human body. Лекарства, которые поступают внутрь организма. So we are going to speak about Kimiko, a PhD student. She has drawn a sketch of a targeted drug delivery for the material and method section of her paper. So what do you think is happening at each stage? So you can see on this picture, there are the letters A, B, C, D, E, F. Do you see them?
Yeah. Yes.
So can you describe any of them? What is happening in each of the separate pictures?
Mhm. Okay, let me try.
Mhm.
So I think that this this is a drug molecules in the cap, right?
Yeah.
And the cap is in a nano size, right?
Right. Mhm.
Okay, so what is happening here? So in the picture A, we see like these molecules that has been, I'm sorry. Sure, I got it. So these drug molecules, they were put into the cap, and then on the picture B, we see that it was like closed, то есть его закрыли, когда вот его
Yes.
положили.
So actually, I'm sorry to interrupt. They put inside some capsule, right? In A. And
yes, they put these drug molecules into the capsule, and then B, they will close it with a cap. Это получается крышечка, что ли, как.
Right.
And then in the picture D, they were like A, B, C. C shows how it is by the chemical receptors connecting to the cell receptor, and on the picture D, we see how, like with help of this receptor, this capsule get into the cell. And after on the picture E, we see how like the capsule is getting rid of its cap. And F, we see the drug molecules that was как это освобождены или выпущены.
They go inside a cell, right?
Yes. And actually I saw that kind of picture when I was on a conference. It was a medical one, but it was also interesting about nanomaterials in the cancer. And the speaker, I don't know, maybe he was a teacher, he was from Moscow, and he was trying to explain us how it could be possible. For example, like we see here cell receptor like D, E, and F pictures. This, for as he described, this is the damaged cell of like cancer. Like there are dead cells, so for healing them, but they use that kind of capsules that would influence only in the known area that they want to heal. Because if they will give like for all cells, it means that even the healthy ones would die. So they need to interact only with the sequence. I don't know. So
yes, you're right. So they are targeted to cancer tumor cells, right? So just only specific cells. So just to affect them, the cells which are affected by cancer. So this is very important in the cancer treatment. And you say that you've seen this picture. Have you seen exactly the same picture? So I mean,
no,
this
not
very
exactly. It was like
similar picture, or exactly the same picture.
Similar, not exactly that, but the structure was the same.
I see. Okay, so perfect. I mean, so Aidana, you've described the process very well, and it shows that it's very important to visualize the process. I mean, if we draw the scheme correctly, if we just show on in the picture, so the main stages of the process. So it will help other people to understand the process very well. And so actually, we are going to listen to the story connected with this picture. So as Chemical describes this process, and you can see here some words which are essential to understand in understanding this process. So the words are given to the right. So this is carbon nanotubes. So this is carbon nanotubes, carbon, какие-то трубочки, пути мелкие, да? So, or CNT, this is the abbreviation. Then magic bullet, magic bullet. You know what is bullet?
Цель.
Пуля, да? Magic bullet, волшебная,
Да. Так же.
волшебная
Да.
пуля, которая проникает, yes? Then chemical receptor, so химический какой-то порт, да, который принимает что-то. Tumor, so this is опухоль, you know. Folic acid, фолиевая кислота, acid, you know. Фолиевая кислота. Folate is фолит, вот какое-то вещество тоже химическое. Swallow, здесь буковки не хватает. Swallow is when we drink water, we swallow water. Swallow. This is проглатывать, глотать. Then inject. Drugs are normally injected by, so if a person is sick, inject, сделать инъекцию, да, ввести с помощью инъекции. And inhale is to breathe in, вдыхать что-то. Now we are going to listen to the description of this picture and...
I'm sorry, may I ask, like, not concerning to this, but как будет тогда опухший, когда что-то опухает? It was swollen? Swallow. Я всегда думала, что...
I don't remember now, actually, so I need to consult some sources, so I don't remember, actually. Well, anyway, we are going to listen and compare, okay? И вы мне слышно вам или нет? Уман, вы с нами?
Да.
Замечательно.
6.1.
Слышно?
Hi, Tom. Do you have a moment?
Sure, Kimiko. What can I do for you?
I'm just trying to write up my paper and, I wondered if you could look through it for me.
Sure. I've got a bit of time now as it goes. Was there anything in particular you wanted me to look at?
Not really. It's my first draft, so just any advice you could give me would be really helpful.
Sure. Let's have a look then. Well, the diagram's nice and clear.
Really? Oh, thanks.
But first of all, you need to explain briefly what's happening, what you did in each stage.
Is the diagram not clear enough?
The diagram's much clearer if you know something about the process, but not everyone who reads this paper will, so you should definitely include a short description.
Okay, I'd better do that then.
Why don't you talk me through it and make some notes as you go? Then you can write it up properly later.
Thanks, Tom. So, the basic idea is that we can use carbon nanotubes, CNTs, to send a drug right to where it's needed. That's why some people call it a magic bullet. To do this, first we coat the surface of the tube with a chemical receptor. For instance, if we want to target a tumor which overexpresses folic acid, then we attach folate receptors to the surface of the nanotube.
Because folate receptors bind to folic acid?
Yes, and then we encapsulate the drug in the tube. This is the part I'm most interested in. Up to now, a lot of different methods to get things into the cell have been tried, but I'm looking at just one of them in my paper. Okay, so if you look here at the first part of the diagram, once the drug is encapsulated, we use a cap to close the open end so the drug can't escape.
And that's when we take the capsules?
Yes, you can swallow them or you could have them injected or even inhaled.
Okay. So then they're in the body, shooting to the target.
And if they're properly functionalized, they should arrive. After that, the capsule is internalized by the cell.
And how does that happen?
Through receptor-mediated endocytosis. Then the tube opens up in order to let the drug out. There are different ways of doing this, but I use biodegradable caps. The cap dissolves and then...
And then the drug can start doing its work?
Exactly. It's released from the tube and starts to act.
Well, that sounds fine so far, Kimiko. If I were you, I'd write that up first.
And then can I get you to look at the rest?
Sure, no problem.
Thanks, Tom. I'll see you later.
Okay, so
Спасибо Тому, что он сократил этот диалог.
кто сократил?
Том.
Том сократил.
Да.
Okay,
Она же хотела детально описать еще.
so I think Tom is a very busy person. That is why it's just he needs to be very brief. Okay, is it easy to understand?
No.
No,
6.1.
just a minute.
6.1.
And actually, this is the text, which this is the script for the what we were listening to, the conversation between Kimiko and Tom. Do we need to listen for the second time?
No.
No. Okay. So if you don't need to listen for the second time,
6.
that you understand, and you can just easily do the following task. The task is to mark the statements true or false. So, Duman, what do you think of the first statement here?
Yes.
Read
True.
it.
True.
True?
Tom asks Kimiko to make changes to her diagram. Kimiko, it's that one.
This is Kimiko is the PhD student, and Tom is her academic supervisor, academic advisor.
Это та девушка, которая была на первом уроке, да, которая брала интервью у Сюзанны.
They are different characters actually. In every class we have different students. I mean, does Tom here really ask Kimiko to make changes, or
Yes.
no? He
So
asked,
why? Because he asked to add some brief definitions about processes.
he asks her to describe, to explain what is happening in the diagram.
Yeah, it's changing anyway.
No, there is no information about making any changes, only just description, explanation of something. Because maybe the first time Kimiko speaks to Tom about her research and about the description of the process. So this is false statement. So as for the next one, Aidana, what do you think about this?
I think it's true.
Some readers may only know a little about Kimiko's research. Yes, so that is why she needs to explain, right?
Yes.
Duman, number 3. What do you think?
Oh my God, some people call nanotubes magic bullets because they can be dangerous. I think no.
No. Yes, this is false statement because it sends the drug to where it is needed. Yes, that's why they call them magic bullets. So Aidana, number 4.
Kimiko's main interest is in the best method for coating a nanotube with the chemical receptor. No, it's false.
What is her main interest?
Is to so her main interest was in the healing of this tumor mean, or getting rid of this tumor.
Mhm. So
Mm,
actually, how to encapsulate the drugs.
yes, how to
Right.
yes, this part. Mhm.
Okay. So, Duman, the next one.
The nanotube can be ingested in different ways. Ingest, how translates?
Just поглощать.
No?
Actually, yes. This is.
Actually, no.
I mean, they say that it can be just swallowed, right?
Ah, da.
Can be injected.
Injected, inhaled.
It can be inhaled.
Да, inhaled. Да.
Можно. So, Aidana, the last one.
Chemical uses only one method to open the nanotubes after ingestion. Yes.
So
I didn't heard that she was telling about two methods.
yes, she was speaking about biodegradable caps, right? Which like dissolve, and this is the way how the drugs are delivered inside the cell. Okay. So what is there? So we have to complete the following extracts from their conversations using the words which are given in green here. Attach, by, coat, dissolves, encapsulated, in, internalized, to, with. You can see that there are several prepositions and the verbs. So, Man, what do you think of время? 1,5 минутки осталось. Хотя бы одно предложение, Думан.
Okay. To do this, we так. To do this, first we.
What can we do with the surface of the tube?
Encapsulate?
Surface of the tube.
Or attack, maybe.
Surface.
Поверхность.
Coating, maybe.
Maybe coat the surface of the tube. What preposition should be used here? Предлог какой? Coat with the chemical receptor, right? If I'm not mistaken. Okay, we have less than 1 minute. У нас меньше минутки осталось, поэтому значит, сейчас сеанс прервется, и мы с вами через 10 минут вернемся к третьему нашему уроку. Окей?
Okay.
And we'll start with this slide then. Начнем как раз этого. Окей.